Welcome to This Explainer. Today, we're going on a seriously fascinating journey. We're going to trace the path of energy, literally watching it transform from raw fire into, well, unstoppable physical motion. Our mission here? To completely demystify one of the most absolute game-changing inventions in all of mechanical history, the steam engine.
Okay, let's dive right into this. At its absolute core, what actually is a steam engine? Well, it's basically a machine that generates mechanical energy from heat energy. You can kind of think of it like a giant translator. I mean, heat on its own just radiates, right? It doesn't push, it doesn't pull. So the steam engine is this brilliantly engineered solution that captures that heat and literally translates it into a physical, moving, mechanical force. Here's our blueprint for today's explainer. We'll kick things off with an introduction to the steam engine, meet the main parts, and then look at the engineering process, starting with boiler pressure generation, followed by piston energy conversion. After that, we'll wrap up with the working principles and uses, plus the advantages and disadvantages. Section 1. Introduction to the steam engine. So we're setting up the foundational concept here of how you take an everyday liquid, just regular water, and turn it into a driving force capable of moving massive, massive amounts of weight. The absolute brilliance of this concept really lies in its simplicity. We take water, we convert it into steam, and we use its pressure to move a piston. By heating the water until it turns into vapor, we create this immense pressure. We trap that pressure and then use that trapped force to push a physical object. That right there is the fundamental heart of this machine's mechanical magic. Section 2. Main parts. Before we actually see this engine run, we need to meet the essential characters that make up the machine. You can think of these parts in three distinct groups: the heat source, the action, and the output. First up, the heat source. The firebox is our instigator. It's the exact place where we burn the coal or fuel. Right next to it is the boiler, which uses that heat to warm the water. Then we've got the steam pipe acting as our messenger, moving that freshly made steam. Now down in the action zone, we have the cylinder. This is the arena where the steam's pressure acts. Inside that is the piston, which is basically the physical muscle moving back and forth. And finally, the output. The connecting rod transfers that raw back and forth motion, and the flywheel, or the wheels, keep the whole shebang running smoothly with their momentum.
Section 3. Boiler pressure generation.
All right, here is where the engineering process really kicks in. Step 1. Coal or fuel is actively burned in the firebox. This creates intense heat, and that heat is directly applied to the water sitting inside the boiler. Step 2. That heated water starts to transform, creating high-pressure steam. Think about what's happening here. We are taking raw, uncontained heat energy and transforming it into a highly contained, incredibly intense physical pressure inside that boiler. It is a massive buildup of internal force just waiting to be unleashed. Section 4. Piston energy conversion. Now for the payoff. Step 1, that high-pressure steam travels violently through the pipe and straight into the cylinder. Step 2, because the steam is under such intense pressure, it pushes the piston forward with incredible force. Boom! Step 3, as the piston shoots forward, the connecting rod moves right along with it, transferring that straight-line movement into the turning of the wheels. Step 4, finally, after the work is done, the used steam gets pushed out via the exhaust, clearing the cylinder for the next cycle. Push, pull, push, pull. And this brilliantly illustrates how these final steps beautifully convert that stored pressure into actual turning mechanical work. Section 5. Working principle and uses. W equals P times V. Now I want to pause here for just a second to really let the elegance of this formula sink in. Please don't look at this and think it's intimidating math. Actually, scratch that. It's not really math at all. It's just a wonderfully simple, elegant summary of the entire machine we just explored. So the crucial point is how these three elements interact with each other. W stands for work, that's the actual movement of the engine. P is the pressure of the steam we generated back in the boiler. And V, that's the volume inside the cylinder where the piston lives. The steam's pressure acting within the specific volume of that cylinder is exactly what creates the final mechanical work. It really is that straightforward. And where did this mathematical principle get applied in the real world? Honestly, almost everywhere. This technology spanned from early railway engines crossing entire continents to driving the heavy machinery of old factories all the way to powering massive ships across the oceans. But you know what? It doesn't just stop in the past. The very same principles of utilizing steam pressure are central to modern power plants, actively helping to generate the electricity we use today.
Section 6. Advantages and disadvantages.
The advantages of this technology are pretty undeniable. The steam engine boasts a really simple design, it creates immense power, and it's highly versatile because it can run on almost any kind of fuel. Wood, coal, you name it. However, the disadvantages are equally significant. These engines suffer from famously low efficiency, which leads to high fuel consumption. Plus, dealing with all that intense heat and pressure results in some seriously high maintenance costs just to keep them running safely.
Which leads us to our final thought for this explainer. Knowing what you know now about the staggering power, the straightforward mechanics, and the notable inefficiencies of this design, is the steam engine just a dusty piece of history? Or, considering those power plants we mentioned earlier, is it still quietly powering our modern world? Keep that in mind the next time you flip a light switch. Thank you so much for learning with us today, and I'll catch you in the next explainer.